In section 12.2, we're going to look at chords and arcs. So chord. Chord is a line segment whose endpoints are on the circle, and an arc is a portion of the circumference. So in this diagram, we have chord AB, and we have arc AB. So the arc is the distance around the circle, the portion of the circumference. The chord is the straight line that connects 2 points on any circle. Okay, theorems. We've got a bunch of theorems, so get ready to write. You're going to have to pause and write some of this down. Theorem 12.4 and its converse. Within a circle or in congruent circles, so within the same circle or within two circles that have the same radius, congruent central angles have congruent arcs. So these two angles are congruent because they're vertical angles. So arc DB is congruent to arc AC. And the converse, within a circle or in congruent circles, congruent arcs have congruent angles. So if I told you that in this circle, if I call this FG, if I say that arc FG is congruent to arc DB, then I know that this angle is also congruent to these angles. Okay? Theorem 12.5. Within a circle or in congruent circles, congruent central angles have congruent chords. Same exact idea, except now we're talking about the chord length rather than the arc length. So chord DB is congruent with chord AC. And the converse, if the chords are congruent, then the angles are also congruent. Okay, theorem 12.6 and its converse. Within a circle or in congruent circles, congruent chords have congruent arcs. So if DB is congruent to AC, if that's given, then I can say that arc DB is also congruent to arc AC. And the same thing in reverse. If the arcs are congruent, then the chords are congruent. All we're saying is that if you have any chord or arc or angle that is congruent to another chord or arc or angle, then everything else is congruent as well. 12.7. I told you there was a lot of writing, a lot of theorems. Within a circle or in congruent circles, chords equidistant from the center, so distance is measured by a perpendicular. If these two are the same, then chord AB is congruent with chord CD. Now everything that we're writing here, and please do pause and take the time to write these down. Everything that we're talking about is going to help us to find missing lengths in a diagram or in a circle. So let's look at one. So here's a circle. I know, because of the measurements, that this chord equals this chord. Therefore, by theorem 12.7's converse, the one we looked at last, congruent chords are equidistant from the center. Okay? So if these chords are congruent, they have to be equidistant from the center. Therefore, I know that x also equals 16. So pretty simple math, but looking at what we know based on our theorems. Another theorem. In a circle, if a diameter, in this case CD, is perpendicular to a chord, then it bisects the chord and its arc. In other words, AB equals FB, and AD, arc AD, equals arc DB. So if CD is a diameter and CD is perpendicular to AB, then it bisects both of those arcs and chords. Another theorem. In a circle, if a diameter bisects a chord, so if a diameter bisects a chord, then it is perpendicular. So now we're saying the converse. If this equals this, then we can assume that it is a perpendicular. The previous one said if it's perpendicular, then the two sides are equal. This one, if the two sides are equal, then it's perpendicular, just our converse. Theorem 1210, last theorem. In a circle, the perpendicular bisector of a chord, contains the center. So any perpendicular bisector of any chord will be a diameter. So again, the last several theorems, 12.8, 12.9, 12.10 are saying the same thing in a different way. So let's do a couple of problems and see what we can do. I want to find R. So the first thing I have to know, this whole chord is 14. If this is a radius and this is perpendicular through the center, I do know that this has to equal this. Therefore, ln is 7, half of 14, and then I can use Pythagorean. 7 squared plus 3 squared equals r squared. 49 plus 9, excuse me, 49 plus 9 is 58. So r is the square root of 58. See what you can do with this one on your own. We're looking for the distance from B to the chord. Okay, again, this was perpendicular, therefore these two pieces have to be equal. This is a radius, this is also a radius, so that must be 15. So I've got 11 squared plus y squared equals 15 squared. 15 squared is 225. And if I subtract 225 minus 121, I get 104. And so y equals the square root of 104. Okay, so get all this down, and we'll do some more in class.